Hello, you're welcome to our lecture series on biological techniques. Earlier, we had looked at the introductory part of the course, the meaning of microscopy and what a microscope is. And we've also looked at the different types of microscopes based on the source of illumination and also the kind of images that are being produced. We have classified microscopes into various types, like the light microscope, the electron microscope, the helium, and the scanning acoustic microscope, and many others. Today's lecture will be on the compound light or optical microscope, and we'll look at the different parts of the light microscope and their functions. So what is the compound or the compound optical or light microscope? The compound light microscope is a microscope that employs visible light to detect small objects or microscopic organisms. It makes use of visible light, the light from the sunlight, in the case of the ones that make use of mirror to reflect light, and also light from electricity, from a light source, a bulb that illuminates the stage or the object for proper viewing or identification. And it is the most common type of microscope, commonly used in most secondary schools and even in most universities, because it is affordable and also readily available for purchase, unlike the other microscopes like the electron microscopes. These microscopes are called compound optical or light microscopes because they make use of two lenses, the ocular and objective lenses. They have two sets of lenses, the ocular lens, that's through which the organism is being viewed, and the objective lens, the one that's closer to the organism. These two lenses magnify the object. That's why it's called compound microscope. And these two lenses produce a magnified image. These two lenses combine to form a magnified image. Now I want to look at the parts of the compound light microscope and their uses. The parts of the compound light microscope and their uses. Now here is a picture of a binocular compound light microscope. Here is the eyepiece that has the ocular lens. Then here we have the revolving nose piece, the neck, the objective lens, the stage clip, the quartz focus, the fine focus, the light source. Then we have the condenser under the stage, the coaxial stage control, as well as the base of the microscope. What are the functions of this part of the microscope? The first one to look at is the ocular lens or the eyepiece. The ocular lens magnifies the objects or the specimen that's been viewed. Though it's also called the eyepiece, where the organism is being viewed through, but the major function of the ocular lens is also to magnify the object or the specimen that's been viewed. Then the second part we want to look at is the coarse adjustment knob or the coax focus. The coax focus is used to focus on the specimen. It's used to move the stage up and down, and as you move the stage closer, the specimen is seen but not clearly. So you now use the fine adjustment knob, which is also used to focus on the specimen. The fine adjustment knob enables you to focus properly and have a clearer view of the specimen. The next part of the microscope is the revolving nose piece. The revolving nose piece is used for changing objective lens used. The objective lens that you want to use or the one you don't want to use, you change it by turning it. And as you turn it, you hear a clicking sound. That indicates that the objective lens is in place and they use it to view the organism successfully. We also have the objective lenses, or they are also called the objectives. The objectives magnifies the object or the organism that's being viewed. The objective lenses magnify the objects that are being viewed, or the specimen that's in the state is magnified. The arm of the microscope is used to carry the microscope. The arm of the microscope is used to carry the microscope. Then we also have the stage clips. The stage clip is used to hold the glass slide. It's used to hold the glass slides in the stage so that they don't move, keep them in place. Then we also have the diaphragm lever. The diaphragm lever adjusts the circumference of light source. The next is the condenser adjustment knob. It is used to focus the condenser. The condenser and the adjustment knob is used to focus the condenser. Then we have the condenser. The condenser focuses light through the specimen, thus increasing illumination of the specimen. It influences visualization of the sample. It focuses light through the specimen, through that opening in the stage of the specimen. The next is the mirror for those that do not have a light source. The mirror collects light and directs it to the condenser. Some microscopes possess electric light source, which illuminates the specimen by directing light to the condenser. Then the stage supports the specimen. The stage, that's where the glass slide has been placed to be viewed. So it supports the specimen. The base of the microscope supports the microscope. Now here is also a binocular digital microscope. We have looked at the various parts of the microscope. The eyepiece or ocular lens magnifies the object, and it is the part of the microscope the user looks through to see the organism. It magnifies the specimen. Then the arm of the microscope is used to carry the microscope. Then we have the revolving nose piece, which is turned to change the objective lens. Okay, to change objective lens used. The stage clips hold the specimen in place, or holds the slides in place for viewing. We also have the coarse adjustment knob that's used to focus on the specimen. The fine adjustment helps you to properly focus on the specimen to have a clearer view. Then we have the condenser here. The condenser is the condenser helps to direct light to the specimen, and the diaphragm lever helps to adjust the light that passes through the condenser. Then this is the coaxial stage control that's used to move the stage forward or backward or sideways. Then we also have the base of the microscope, that's the bottom, which is where the microscope used to sit on the bench that's being viewed. This digital microscope also has a camera that is able to capture the specimen, the image of the specimen, which is being displayed on a screen. So this is a binocular microscope. Now, how can you use the microscope? How is a microscope being used? We want to look at how to use the compound light microscope. To use the microscope, you must know how to focus on the specimen, adjust the condenser and diaphragm to optimize visualization of the sample. You need to know how to focus the sample, to adjust the condenser and the diaphragm to optimize visualization of the sample. For binocular microscopes, you must also set appropriate interpupillary distance. Interpupillary distance means the distance between the pupils. So you have to adjust it and adjust the diopter ring to focus both eyes on the sample. Now, want to look at how to focus on the specimen, focusing specimen. The first step is that you should plug a microscope in the extension ports and switch on the light source or the power. That is the first thing. You plug it just as every other electronic device. You plug it and then you switch on the light source or the power. You switch on the light source or the power. For microscopes that do not have electric light source, adjust the plane mirror under the stage until light is properly centered and the stage is well illuminated. The second stage in focusing on the specimen is that you place your specimen or the tissue to be studied on the glass slide. Okay, after putting on the microscope slide, after putting on the microscope, the power source, you now place the sample or the tissue to be studied on the glass slide. Then a drop of water or moisture can be added to keep the sample or tissue from drying up. After placing it, you now cover the sample or tissue with the cover slip, which is optional. There are some samples that do not need a cover slip. Okay, so you cover the sample or tissue with the cover slip and place the slide on the stage and secure it with the stage clips. Okay, put the slide in the stage and secure it with the stage clip. Then the third step is to move the objective into position over the microscope slide. You move the objective into position over the microscope slide or glass slide. You turn the revolving nose piece, ensure that you hear a clicking sound. Okay, you choose the right objective you intend to use. The fourth stage is that you now lower the objective with the coarse adjustment knob or the coarse focus until it is about 0.2 to 0.5 centimeters above the cover slip or the glass slide. This can be achieved by viewing the operation from the side of the microscope. You view the operation from the side of the microscope, not through the eyepiece, but from the side, so that you see the level the stage is getting to, so that the objective do not touch the cover slip or the glass slide. The fifth stage is that after you have looked through the side and have adjusted it to the appropriate distance, you now look through the eyepiece and slowly turn the objective upward until the object or organisms is visible. You slowly turn it with a fine adjustment knob. Then use the fine adjustment knob to bring the object or organism into focus. You now use the fine adjustment knob to bring the object or organism into focus. Then you study or identify the object or the organism. You study while you're viewing, you study it to know which organism you properly identified. Now, the next we want to look at is magnification. After identifying the object or the organism, you need to also calculate the magnification. And what is magnification? Magnification is a ratio of the image size to the actual size. The ratio of the image size to the actual size. It is the apparent enlargement of an object. When an object is made bigger than the way it looks, like those bacteria you see on the microscope are not organisms you cannot see, but the lenses in the microscopes were able to magnify them, to make them bigger for you to see. So that's what magnification actually means. The magnification of an object is the multiple of the eyepiece or ocular and the objective lens magnification. You multiply the eyepiece magnification by the objective lens magnification. For instance, the eyepiece magnification is usually, of most of optical microscopes, is usually times 10. So, and if you are using an objective of, let's say, times 4, you multiply 10, which is the ocular lens magnification, by times 4. which gives you a magnification of times 40. Your compound light microscope has 3 objective lenses, objective lens magnifications. It has the scanning, the low power, and the high power magnifications. The magnifications of the objective lenses are written on each of the objectives. In addition to this, the ocular lens, which is the eyepiece, has a magnification. Okay, the ocular lens usually has a constant magnification of times 10, while the objective lens magnification can vary from times 4 to times 10 to times 100, times 4, times 40, times 100, times 10. Okay, those are the magnifications of the objective lenses. Now, the total magnification, just as we have said, is equal to the ocular or eyepiece magnification times the objective lens magnification. Now look at this table. Here are the objective lens magnifications. The scanning objective has times 4 magnification. The low power objective has times 10, while the high power has times 40. While the ocular lens magnification is constant, it has 10 times 10 magnification. The ocular lens, the lens that you look through, has times 10. Then the objective that's below has times 4, times 10, and times 40. Now, total magnification is a multiple of the ocular lens magnification and the objective lens magnification. So if you multiply 4 by 10, you have 40. 4 times 10 is times 40. So the total magnification, if you're using the scanning power microscope, is times 40. Then the low power magnification would have 10 times 10. That's the low power is usually times 10, while the ocular lens remains the same, times 10. 10 times 10 is times 100. Then you have the high power magnification, which is times 40. So times 40 of objective lens magnification by multiplied by the ocular lens magnification of times 10 will give you times 100. So the total magnification, to know the size of the organism, if you are using the scanning power, which is times 4, that means the magnification is times 40. If you are using the low power magnification, which is times 10, it will give you times 100, which is 10 times 10. Then if you're using times 40 magnification, which is a high power, you have 40 times 10, which will give you a magnification of 400. So that's how to calculate the magnification of the object being viewed. Thank you very much for watching this series, this particular video. Keep watching and subscribe to our YouTube channel. Thank you for watching.